Yesterday in class, you had some time to kind of experiment with some of the systems of equations that have three variables. Today, we are going to give a little bit more structure to that and give you some rules and some tips and things like that on how to maybe doing this more efficiently. So take a minute to write some of these down, but I'm going to go through and explain them as you are writing them down, or pause if you need to. First of all, the main idea of how to get started is to reduce two of the equations down to the same two variables. In other words, if you want to get it down to x and y and eliminate your z, then you have to do another equation that includes the x and the y but eliminates the z. Because if you have one that has x and y and you have another that has y and z, that doesn't get you anywhere. It doesn't really help you out. So you want to make sure you make your life easier. And one thing to do is to go down to the same two variables. Now, which variables? It just depends on the situation. You know that sometimes the y's drop off easier. Sometimes the z's drop off easier. So just do whichever one you can with one of them, with one of the equations, one of the variables, and then go back to the other equations and try to solve for those same two variables. Then you can just do your regular elimination or substitution from there. Another thing is, remember to use both substitution and elimination, whichever one is easier for the situation. Some people get so stuck on they only want to use substitution or they only want to use elimination. But the problem is that makes more work for yourself, and the more work you do, the more liable you are to make some mistakes. So in order to make it easier for yourself and make fewer mistakes, use substitution when it works best and use elimination when it works best. Another thing is avoid fractions. Sometimes, like with elimination, sometimes people say, oh, I can divide this by 4. But then when they divide by 4, they end up with a bunch of fractions. Try to avoid fractions as much as possible. Sometimes they're inevitable, but if you can avoid it, try to avoid them. Another thing is to organize your work. If you are not organizing your work, it's going to be difficult for you to go back and find where there is a mistake, if there is a mistake. If you have them labeled, then we can see what your work is and we can go from there and just make it a lot easier. But make sure you're organizing your work. Also, when I grade it, I need to be able to see it. So if you've made a mistake somewhere in the middle and I'm grading your paper and I can't tell where your mistake is because nothing is labeled, I'm probably going to take points off. If you're labeling it and I can follow it along, I'm going to give you some partial credit for the things that I can see. Another thing is you have to use all three equations. You cannot just use two of them. Because think of what you're doing. If you have these equations and you are only using two of them, then you're really only finding the intersection of two of them. You have to use all three of them so that you're getting all three numbers. And of course, I think we talked about this the other day, that these are actually planes that are intersecting when we do this. And so if you're only doing two of the planes, you're only getting part of the answer. You need to make sure that you're getting that third one also so that you get the entire answer. When one variable is solved, plug it into the other equations to simplify those equations. In other words, if you can get something down to y equals, for instance, then take that y and plug it into the other two equations, and now you're down to just x and z, and then you can solve those. So use one. When you have one solved, go ahead and use it, because then that just makes everything else so much easier. When you can get one of them solved, you're almost done with the problem. Finally, when you check your answer, it has to work in all three equations to be the right answer. Kind of getting back to what we were talking about over in the margin here, that if you're only checking in two of them, then it's only working for two of your planes. But in order for it to work for all of them, you have to check it in all of them. Okay, so those are some tips that you can use as you're doing this process. There aren't a whole lot more of formal tips I can give you at this point. Now, we're going to go on and we're going to learn some other things that are going to make it a little bit easier. But as far as what we know so far, just use some of these pointers so that you can make the job a little bit easier for yourself. Now, another thing is that we will have some where it is no solution and many solutions. Let's get back to thinking about those planes, that we could have one plane over here, and we could have another plane over here, and we could have a third plane. Well, let's just say it's over here, for instance. Okay, we have three planes, but they are not intersecting. And if they are not intersecting, that's going to be a no solution. And many solutions is going to be similar to what we have done in the past, where maybe the planes are on top of each other, things like that. So just keep those in mind. So when we do these problems, algebraically, it's going to be very similar, where you end up with something like 0 equals 0 or 8 equals 9, and it doesn't equal 9. So there might be some situations where you have some of these that don't really make sense, and you just have to decide, does that mean no solution or does that mean many solutions? So let's go ahead and get started here. I am looking at this, and I am looking at maybe the top two equations that I'm going to label this one L1, and sorry, that's supposed to be a 1. Because I have different colors, I might color code them also to make it a little bit easier to follow along. So if I label that one L1, this one L2, and finally L3, that's a good habit to get into so that you can follow your work. All right, I'm going to take L1 and L2. I'm going to take L1 just the same way it is, 3x minus y plus 2z is equal to 4. And then I'm going to take L2 and I'm going to multiply it by -1. So when I multiply that by -1, I get a -2x plus y minus 3z is equal to -7. Because I could see really quickly that those y's are going to cancel out. So now if I add these together, I'm going to get what I call L4, and I'm going to add these together and I'm going to get x, the y's drop off, minus 1z is equal to -3. Okay, I dropped off my y's. I'm going to go see if I can drop off a y with another combination. So maybe what I can do is I can take 3 times L2, and 3 times L2 is going to be 6x minus 3y plus 9z is equal to 21. So 3 times 3 times 3 times 3. And then I'm going to add to that my L3, and L3 I'm just going to keep as it is, -9x plus 3y minus 6z is equal to -12. And the reason I wanted to match my y's up to make those drop off is because the y dropped off over here. So this way I can make my y's drop off again. So now if I add these, I get a -3x plus 3z is equal to 9. And I'm going to call this L5. Okay, now I can combine L4 and L5. So I'm going to take 3 times L4. And if I take 3 times L4, I'm going to get 3x minus 3z is equal to -9. Do you see what's about to happen? I'm going to add these together and I get a 0. Add these together, get a 0. Add these together and get a 0. And I think you know what that answer is, right? It's either no solution or many solutions. In this case, it is many solutions. Now, there are times in math classes that you can't just say many solutions. You actually have to say what the solutions are. Now, we are not going to get there in this class. That might be something for a pre-calculus or maybe a college algebra class, but we're not going to get there. If we run into this situation, we are just going to say many solutions and we're going to move on. Okay, just to reiterate, I got rid of my y's, so I got rid of my y's again, and then I'm labeling my work so I can follow along very easily and see if there was a mistake somewhere. And then a 0 equals 0, that means many solutions. Okay, let's turn the page. I'm looking at this. The bottom one only is missing an x. So again, I'm going to label, this is my L1, this is my L2, this is my L3. L3 is already missing an x. So what I want to do now is I want to get rid of my x on L1 or L2. So would you understand it if I said L1 minus L2? Because that way I don't have to do my negative and all that. So in other words, I can subtract these. Just like you can add them, you can also subtract them. So if I subtract them, the x's drop off. I have a negative y, I'm subtracting. I'm going to write myself a note, I'm subtracting. Negative y minus negative 4. Well, negative y minus negative 4 is like negative y plus 4y, and that is 3y. 3z minus 6z is a negative 3z. And 6 minus 10 is negative 4. Okay, I'm looking at my L3 and it looks like I can take that multiplied by 3. So that's going to give me 3y minus 3z, minus 3z is equal to negative 6. And you know what? Maybe I should have done a negative to make it easier. So negative, negative, positive, positive. All right, I'm going to combine these. That drops off. That drops off. This comes out to be a 2. Does 0 equal 2? No. This is a no solution problem. So that's all that we need to do today. The main emphasis was just to give you a couple of pointers on how to make this easier to solve. So that's what these are about. And then to show you that sometimes it is a many solution problem and sometimes it is a no solution problem. And that's it. So today's homework, again, will be more of these, but they'll be a little bit shorter because I think you could see when I did both these problems, it was pretty quick that we found out it was no solution, many solutions. And so that's all. And then so today's lesson, like I said, it's going to be more of the 3 variable systems, but there will be a little bit shorter work because of the no solution, many solution. And that's it.